Question 5, recall the meaning of sine and cosine ratios. Connect these meanings to why sine starts at the axis and cosine starts max. So I started off by drawing this table, right? And some of these questions we already did during Unit 6, Lesson 1. So it's like a recap. And so briefly go through it. Hopefully it feels like recap to you. So for sine x is equal to y over radius. So in this case, we have 0 degrees, and we want to actually use the unit circle so you can look at the full picture of what's going on. But my y is equal to 0 and r is equal to 1, and I'll show you in a second why. So I have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Sine x is in terms of y. Cos x is in terms of x. We have the following. So I was saying that since sine 0 degrees is right here, that means my y value is 0 and my radius is 1. And so I'm going to have 0 for this. And that is why my sine starts at the axis, because I'm starting off at a value of 0. So for sine 90, I have an angle right there, and that y value is equal to 1. Sine 180 is over here. That's the y value, so I'm going to look at this. So I'm going to get sine 180 is equal to 0. Sine 270 is right there. I'm looking at the y value. Y value is negative 1. So sine 270 is negative 1. Sine 360, we're back here. So then you're going to get this as your answer because our y value is 0 there. So as you can tell, you basically have the x and y axis. You start there. You're going to go up to 1, down to 0, down to negative 1, and up to 0. Let's look at cos x. Well, cos x is cos 0 degrees equals, well, x over r equals. So that means I'm looking at the blue portion, and this is the coordinate that I have. And so it's going to be 1 divided by 1 because the radius is 1 for a unit circle. So this is going to be 1 over 1, which is equal to 1. And so the cosine is going to start here instead. So your graph, you're going to start here and you're going to make your way up. So for cos 90, we are right there. I'm looking at the x and the value is 0. So hopefully you're getting the visuals now. 180 degrees, we're right there. The x value is negative 1. For 270 degrees, the x value is 0. At 360, the x value is 1. So for sine x, again, you start here. So we can say this for sine x starts at the coordinate 0, 0. Cos x starts at 1, 0. In general, any point on the circle can be defined as for unit circles of radius 1. So we said that sine theta is equal to y over r. Well, for a unit circle, radius is going to equal to 1. And because of that, you get y over 1 equals sine theta. And you have y equals sine theta as a result. For cos theta, you have cos theta is equal to x over r, and you have a radius of 1 as well. So you have x over 1 is equal to cos theta, and so x is equal to cos theta. And so as a coordinate, well, how are you going to write that down? Well, if you have x over x comma y as your coordinate, instead you have cos theta comma sine theta for a unit circle. For circles of radius r, so you're dealing with the same idea. You have the same formula. Sine theta is equal to y over r, or cos theta is equal to x over r. This time you're solve for y, or solve for x. Well, you would simply do cross multiplication. And when you do that, you're going to get y is equal to r times sine theta, and x is equal to r times cos theta. So your coordinate, instead of having x comma y, you're going to have r cos theta and comma sine r sine theta instead. Question C, what is the new location of the point 6, 0 that was rotated about 55 degrees? Well, this is my x, this is my y. So step 1, I'm going to consider what this looks like on relative to a graph. So I have my x and y axis, and I want to draw where 6, 0 is. Well, 6 is over here and 0 is here. So I start off there, and they're telling me I'm going up by 55 degrees. So here is my terminal arm, and I need to figure out what my x, what my y is, and that's my step 1. Well, in order to figure this out, I need to figure out some details. Like, what is my radius equal to? I can kind of figure out I like drawing this in terms of a right angle triangle. So, for example, if I know this is x, and this is y, and this is r, I will need to figure out what r is eventually. So I need to figure out what my r is, so I'm going to use the Pythagorean theorem. So I have 6 for x, 0 for y, and it's 36 plus 0 equals r squared. R squared is equal to 36. And I'm going to square root both sides to get that r is equal to 6. And I'm only going to grab the positive value because we're talking about radius. And so I have r is equal to 6. Because I'm dealing with radius 6, between 6a and 6b, which one am I going to use? Well, because this is not a unit circle and it's a circle with the radius r, that means I'm going to follow this. So that means my new point is going to be of the form r cos theta, comma r sine theta, and that's what my new x and y is going to be. And so, simple enough, because I have figured out the formulas already and figured it out through this process, I'm just going to sub it in. So I have an r value of 6. So I have 6 times cos, and the angle theta was 55 degrees. So 6 cos 55. Keep in mind, you do have to put the 6 in front of the cos 55. If you put 6 in here, you're making this 6 an input. It's not. 55 is the input of cos, and this is a pack together, but 6 should not be anywhere near here, and it would be bad format if you stuck 6 over there because it's a little confusing. Anywho, so we have our value of 6, and we have 6 sine 55 degrees. And when you figure that out using a calculator, and in this case, why is it that I'm not going to do the exact method? Why do you think I said, okay, use a calculator? Well, 55 degrees, I'm kind of doing it in my head, but 55 degrees will not have a related acute angle that will make it like a special triangle. It'll never really have a related acute angle of 45, 30, or 60. So that's why I'm going the non-exact way and going from there. And then, so when I work that out, I get the value of negative 5.80, comma 1.55. Question 7. I hope you're getting more comfortable with drawing your sine x and cos x. It takes time, but it becomes like drawing. Okay, so this is 360 degrees. This is 180 degrees. and this is negative 90 degrees. Okay. So I know that I want a max of 1 and a negative 1. So in this version of this graph, they said for f at x equals sine x and g at x equals cos x, sketch both graphs on the same grid, right? And I'm going to start off by drawing, let's say, my sine x. So my rule of thumb is start at the origin, go up to the max, hit the axis, hit the minimum, and hit where it came from, returning to its original kind of position in terms of y. It's two little waves. I have to always remember that I'm working with 5 coordinates. And I'm simply going to connect the dots. And there we go. We have f at x equals sine x. Because I extended this domain to be beyond, what I'm going to do is I'm going to extend this one more time so that it says negative 180. Okay, when I do that, this is what it's going to look like. Well, I know that this is one cycle. And if it was to back up a bit, it's going to hit its minimum instead and then return to the axis. So this is what 1.5 cycle looks like. And there's a nice f at x equals sine x. And now I'm going to focus on the cos x. Cos x, I remember I start from the max with respect to the y-axis. I know at the midpoint it's going to hit the minimum because it's one big curve and then go back to its max. And so it has to hit the axis along the way because it makes sense that you have to go through this part midway. And so this is my g at x, which is equal to cos x. Same idea as the green graph. I'm going to extend it. So the way it goes, I'm going to connect it so that this coordinate is at negative 90. So it's negative 90 comma 0. And then it's going to hit its minimum if we were to work our way backwards. So this is in terms of theta, and this is in terms of, I'm just going to say y, just to generalize it and say this is the y value. I have this beautiful graph, and now we can move on to the actual question. It says negative 180 to 180 degrees is our new domain. That means I'm actually going to look from here to here. I'm going to dismiss this other part that's kind of not really needed. And basically the way you're looking at it is, okay, this is my one cycle and this is my other cycle. That's fine. Or I'm focusing more on that part of the graph. So for these kind of questions, you have to have been good with like the functions unit and be comfortable with it. But hopefully, because we're coming back to it kind of in a cycled way, you can see what I'm talking about. So f at x is equal to 0, it says. Well, if that is the case, and I need to find the x values that is corresponding to that, it's just basically saying y value is 0, what x value makes it true. That's like the non-function way to think about it. Okay, so that means I am looking at the green graph, by the way. Okay, so that means I'm looking at the green graph. Green graph was a sine x. So I'm just going to write it so that I don't have to think too much and say, okay, when is my sine x equal to 0? Okay, so that means I'm going to use a little highlighter, yellow color. So I noticed that my y value is 0, because that's what it really means. Right here, right there, right there. Okay, and then I'm going to state where I see that. So x is equal to negative 180 degrees, 0 degrees, and 180 degrees when the sine values are going to be 0. I hope you see that. Moving on to g at x equals negative 1. So with g at x, remember, these function names helped us identify which function I'm talking about. So I didn't have to rewrite sine x and cos x again every time. So let me just rewrite it. So gx is equal to negative 1. So I need to find where my y value is equal to negative 1. More precisely, in function notation, cos at x is equal to negative 1 where? And I'm going back to the graph, grabbing a highlighter. And for g and x, that means I'm looking at this graph. And I notice that hits negative 1 right there and right there. Now I need to interpret what that means. So I noticed that this is occurring at x is equal to negative 180 degrees and at 180 degrees. Final part, f at x equals g at x. So let's interpret it. That means I need to write it so that, okay, I'm just going to rewrite it once. And then sine x is f at x and g at x is cosine x. So what does that mean to you? Try to interpret that for a second. So what this means is, where is my y value going to be the same for these two functions? Where are they going to meet? When are the y values? You basically need to figure out at what x value will these two graphs be equal. So we're going to figure out where the graph meets. Okay, so for example, if you have y equals x versus y equals 1, they are going to equal when x is equal to 1. Why did I get that? Well, I basically said, well, this is like my left side, this is my right side. I equated them, and I get x is equal to 1. And I can quickly find out what y value is, plugging it into this equation, but y is going to always equal 1. Because of that equation. And so the coordinate where they're equal is 1, 1. You're using that same idea for this. You want to know where the graph meets, so you're going to equate the two. And you're trying to figure out when that occurs. So according to our graph, we have that the coordinates that the graphs meet, and those are the two angles. So we know that the value is between negative 180 and negative 90, and between 0 to 90, but it's kind of hard to figure out exactly when. But there are a couple of ways of doing it. I mean, you can look at the graph and figure it out and do it that way. Algebraically, it might be hard to figure it out, like sine inverse, cos inverse. It might be hard. However, if you reflect on what a special triangle looks like, so this is a special triangle, and there's only two special triangles, right? And try to remember when you had a situation where the sides didn't matter, like whether one was adjacent or opposite, because there are two special triangles, one that deals with 45 degrees and the other one is in terms of 30 degrees and 60 degrees. So I do remember that with the 45 degree triangle, this is what it looks like. It's a simple triangle with side lengths of 1 and a square root of 2. So when we do that, and if this is our angle of interest, this is our adjacent and this is our opposite. Notice that it doesn't really matter which one I choose as adjacent or opposite, as in like the values for adjacent and opposite are the same, so it doesn't really impact what your answer is. So that means that your related acute angle is 45 degrees. And therefore, by kind of logically going through this question, we find that the first angle is 45 degrees. Well, if that's the related acute angle, so we're dealing with 45 degrees here. So that looks about right because you have an angle that's 45 degrees and it's hits and they are interacting. The other angle has to be between negative 180 degrees and negative 90 degrees. So keeping that in mind, if you think of it, so that means that my quadrant, my angle has to be right there. And so I'm going to draw that out. And if I put 45 degrees there, that means my terminal arm has to be negative 135 degrees. And therefore, you can say that the answer to this question is x equals 45 degrees and the other angle is negative 135 degrees. It was basically the middle value of the in-between. So see how this was 90 degrees, and so in-between is 45 degrees. And then this was negative, well, whatever 180 plus 90 is, that's 270. 270 divided by 2 is negative 135 degrees.